So let's take a look about the parametric function. Yeah. So in parametric function, actually, the variable that you are looking for is x and y, but they are expressed in terms of another variable, which is in this case is t. And we have t here. Normally t stands for time, but it's not always. But in this case, let's take a look about this geolocation. So we have the geomapping. So let's say like all the locations are geomapped like this in x and y axis. So for example, you observe an object, misalnya apa ya, motor gitu ya. Kayak Chef View ini kan sukanya motor gitu kan. Let's say motornya mulai dari posisi 00. So meaning that now the position is here. And then later, let's say this motor move like this motion, like go like this. Okay, let's say move like this. Kind of like this, okay? And this point actually represent different time period. Let's say this one is time equal to 1, this one is time equal to 2, so on and so forth. Artinya ini adalah gerakannya Cevio selama dia berkendara gitu ya. Ini dilihat dari atas drone misalnya, dia geraknya tuh gini, gini, gini. Bukan artinya dia naik turun ya. Dia tetap ada di 2 dimensional, tapi kita lihatnya dari langit ya. Dia geraknya gini. Oke? Okay? And we also can use different graph to graph the motion of this object by using x versus time and y versus time. Because both position, like the coordinate of x and y, are connected by time, no? Pasti semuanya connected by time. So for example, when the time is 1, 2, 3, 4, 5, and 6. When the time is 1, 2, 3, 4, 5, and 6. Let's take a look. When the time is 1, koordinat x-nya Cevio ada di waktu 0 dulu ya. Waktu 0, the coordinate of x is x, 0, ya kan? When the time is 1, then the coordinate of x will be almost 1, right? So 1, 2, 3, 4, 5, 6. So it's almost 1. Jadi waktu 1 detik mungkin Cevio ini ada di sini. And then when the time is 2, it's exactly at x equal to 1. So it's exactly at x equal to 1. When the time is 3, it's exactly at 2. Right? Bisa bacanya? Waktu 4 di 3. When it is 5, it is about 4.5. Like almost 5. And then when it is 6, it is still 5. So in terms of horizontal motion, dx, the position of Cevio move like this way. Across time. Enggak, saya tulisnya 4,5. Ini. Okay. Now let's take a look the y. Yeah, let's take a look the y. When it is 0, it is 0. When it is 1, it is exactly 1. So okay, 1, 2, 3, 4, 5 only. Yeah. 1, 2, 3, 4, 5. So 1, 1. And then 2 is 2.5, so like around here. And when it is 3 is go back to 2. When it is 4, 1 point something. When it is 5, exactly 1. When it is 6, 3. So in terms of the vertical motion, it will be something like this. Okay? So this function actually is the function of x as the function of time. Well, this one is the function of y and also in term of time. Okay? But actually yang kita lihat itu yang ini, betul? Kan kita nggak bisa lihat time-nya ya kan? Yang kita lihat kan positionnya aja. Berarti dia geraknya lagi gerak kayak gini beneran. Nah kalau yang ini bukan gerakannya ya, ini cuma posisi dia over time. Jadi bukan berarti dia geraknya naik gini, bukan. Yang ini yang sesuai dengan gerakannya. For example, if the function that I know only this, so I don't know the function of this, yeah. I don't know the function of y equal to fx, yeah. I don't know the function of this, nggak tahu. But I have to find dy over dx by using these functions. So then we use so-called parametric function then, yeah. This is parametric function. As the name parametric function, it comes from the word parameter, right? The parameter. And in this case, the parameter is the time. So they use another variable, the third variable, to define x and y. Okay? So how to do this? Yeah, how to do this? In order to get the dy over dx, firstly, out of this function, you find dx over dt. So the derivative with respect to t. Because your function kan dalam t, gitu kan? And for this one, you also try to find the derivative of y in term or with respect to t. So the dy over dx will be just the ratio between dx over dt over by dy over dt. We have the parametric equation of x equal to r cos t and y also r sin t. Okay? And in this case, you know that r here is constant. Yeah? R is a constant. Okay? Now, the question is, you have to find the y prime and also y double prime. Okay? Earlier, what we learned is only y prime, yeah? Y prime is the same thing like dy over dx, while y double prime is d square y over dx squared. Let's find the dy over dx first, yeah? How to find it? We have to find the dx over dt first. Dx over dt is the derivative of x with respect to t. So then it just become negative r sine t. And then you also have dy over dt, the derivative of y with respect to t. So then it becomes r times cos t. Because the derivative of cos is negative sign. Yeah. Yeah. Now, we answer the first question, y prime. Y prime is just simply dy over dt over by dx over dt. Dy over dt is r cos t over by dx over dt is negative r sin t. So then together it becomes negative cotangent t. Sorry. So this is our y prime. Now, let's learn how about y double prime. Yeah? If we have y double prime, the symbol is like this, d squared y dx squared. So it will be equivalent to the derivative of your first derivative, but with respect to t, because our function here is just in term of t, over by dx over dt. So then this will be positive cosecant square t over by negative r sin t. Yeah. So then this becomes negative 1 over r or negative cosecant cube t over by r. because you know 1 over sine is cosecant. Yeah. So maybe you also ask, how about the third derivative, y triple prime? Then it will have the same pattern, right? The symbol is d cubed y over dx cubed. To find this, you have to find the derivative of the second derivative, but you do the derivative with respect to t. And because you do it with respect to t, so we have to over this by dx over dt again. Okay? Or on your handbook, like we can see that one is just d of y double prime with respect to t over by dx over dt. This one is simpler, yeah, it's easier. So, firstly, we try to differentiate this, and this will be chain rule, betul ya? Kenapa? Gak ditanyain. Misalnya minta yang ketiga. The chain rule of this. So this will be, wait, negative 1 over r is the coefficient, right? So times with 3 cosecant square t, right? Because we assume this cosecant t, right? So we're gonna do derivative for this. So times it with negative cosecant t times cotangent t. That's all. Betul kan? Because we assume this as x cubed. So it becomes 3x squared. But it is not x, so we times it with the derivative of cosecant, which is negative cosecant times cotangent. Over by dx over dt. Our dx over dt is negative r sine t. So then it becomes positive 3 cosecant 4t times cotangent t over by r square. 3 tapi tambah ini lagi. 2, 3 sepersin kan kosekan juga. Selesai. 1b, you can also try by yourself. X equal to t square plus t, while y equal to t square plus, negative t. So from here, right, you can find the dx over dt first. This will be just simply 2t plus 1. But for this one, dy over dt. So it will be 2t minus 1. Now, the question is the first derivative, which is dy over dx. The derivative of this will be u over v. So, u prime v minus u v prime over by v square. Let's rearrange this. I think the 40 will be gone. 40 minus 40, right? Plus 2 over by 2t plus 1 squared. So then it simply becomes 4 over 2t plus 1 squared. So to answer y double prime, which is the d square y over dx square, it's just simply the derivative of y prime over time over by dx over time. So then this one is this 4 over 2t plus 1 square over by dx over dt. 2t plus 1. Hah? Ini sudah saya turunkan di sini. Jadi tinggal saya copy saja. Yeah.